Hey, 8th grade math, happy Wednesday. I hope you had a wonderfully long weekend and Monday and Tuesday off of school. And now we get back into this school week. We're already halfway done. We are starting one of our last lessons of this chapter, and it's called Indirect Measurement. But it goes along with the last lesson that we did on proportions. So we're going to be using proportions to help us today. So hopefully that assignment went well for you, and you can use what you know from there to help you solve these problems here. Indirect measurement says that we're using similar figures to find distances that are difficult to measure directly. So for example, most of the time we are talking about objects that are very tall, large, hard for us to measure. Imagine that you have to find how tall the tallest tree in Zuni is. It could be difficult to climb the tree and take a tape measure and drop it from the top to the ground to measure it accurately, or get big machinery in here and try and get to the top of the tree. Those kind of things are hard. So a way that they can measure things like that is through indirect measurement. So indirect means that instead of us actually standing there and measuring a tree with a tape measure, we can use other things to help us measure it, things not exactly directed to measuring the tree itself. And we use something called shadow reckoning, which is a fancy word for just saying we're going to use shadows, the shadow the tree makes on the ground and the shadow of like our body next to the tree, to help us find lengths and measurements to help us find the length of that tree. For example, in this diagram here, we've got Bobby, and Bobby is 6 feet tall, and he's standing next to the flagpole in front of his school, and they want to know how tall is the flagpole. But instead of Bobby having to try and shimmy up the flagpole to measure it, we are going to use shadows. So you'll notice in this picture, he's 6 feet tall, and he casts a shadow himself that's 10 feet long. And this flagpole from the bottom out casts a shadow that's 85 feet. So the only thing we're missing is how tall is this flagpole? Here's my terrible attempt at the exact same drawing. So what we're going to do is use proportions. We did that on our last lesson doing similar polygons. We took numbers from each of the different shapes and we put them into a proportion. We're going to do the same thing here. So what we're going to do is first take all the information that we have on Bobby. So we know that Bobby is 6 feet tall and he casts a shadow that's 10 feet. So I'm going to put all of Bobby's information together on the same fraction. I'm going to put 6 on the top and 10 on the bottom. It doesn't matter which number you put on the top and which you put on the bottom, as long as the numbers over here coordinate, one of those words. They have to be in the same position. So notice the first number was how tall Bobby is. So now the top number of our second group of numbers has to be how tall the flagpole is, which we currently don't know. So for right now, we're going to put an X up there. The bottom number of our first fraction was how long Bobby's shadow was. So the bottom number over here is going to be how big the shadow of the flagpole is, which is 85. Now this looks exactly like our last couple lessons. We've set it up in a proportion, and all we have to do is cross multiply these two numbers and divide the leftover one, and that's going to give us what our missing number is. So we're going to butterfly these two numbers, 6 times 85, and I'm going to use my handy dandy calculator. 6 times 85 equals 510. And then because we have only one number left and we're solving for this X, I'm going to divide my leftover number into 510. So 510 divided by 10 equals 51. So what that is telling us is, having used proportions and shadows, we can guesstimate with a close guess that the length of this flagpole is 51 feet based on its shadow and the shadow of Bobby. So that's what we're going to be doing on our assignment today. You have front and back side. And the back side are basically just written in story problems. So instead of having a picture for you to look at, you're going to have to draw the picture that it tells you. So we're going to do that here on our next one, just so you know you can do that. So here we go. Oh, Bobby. No wonder I used the name Bobby. It's in my next example. Bobby is 5 feet tall. That's important information. So I'm going to draw Bobby on my paper. And Bobby is 5 feet tall. That's all we know so far. And he casts a shadow that's 4 feet long. So I know that Bobby's shadow over here is 4 feet. Bobby is standing next to a tree that casts a shadow of 10 feet. How tall is the tree? So it's the same type of problem we just had. We now are finding the measurements of this tall tree next to Bobby. We don't know how tall it is, but we do know that the shadow of the tree is 10 feet. So, tall tree, we got to find out how tall. Bobby is 5 feet, his shadow is 4, and the shadow of the tree is 10. So we're going to fill out a proportion again. We're going to start with the information we know about Bobby. Bobby is 5 feet tall, his shadow is 4 feet. So I'm going to write 5/4. Now I have to find corresponding sides over here. That's the C word I was looking for, corresponding. So since Bobby's height, the number going up and down was on top, this number going up and down has to go on top, and that's our X. We're trying to find how tall the tree is. And I know that the tree's shadow is 10 feet, so that's going to be my bottom number. Now it's a proportion that we know how to solve. We're going to cross multiply 5 times 10 and divide our leftover number 4. 5 times 10 is 50, and we divide it by 4. So it comes out to 12.5. So not a terribly tall tree. I drew that almost proportionate to how tall Bobby is, 12.5 feet based on filling out our proportion. So indirect measurement, your worksheet, let me quick grab it. Looks like this. So on the front, you have these pictures here to help you. On the back, you're going to be doing the same type of thing, but the story problem. So use this space here to draw out what it says. Paco is 6 feet. He casts a shadow that's 12. So you'll draw Paco, you'll draw his shadow. Read it, fill it out as you go. Let me know if you have any questions, but you're just going to be solving proportions.